a nice little square in here. Or vice versa with the K. And so notice where we have to complete the square. On the left-hand side, Jeff, take one of each of those. On the left-hand side is where we have to complete the square. So whichever one has the square, we're going to isolate on the left-hand side, and we're going to complete the square. So if we look at this, and this is how you can tell that this is a parabola. It's got two variables, but one of them is a square. So usually you have your x squared, an x, and number. So this time you can either have a y squared or an x squared. So we're going to get the y's to one side. So we're going to add y squared and add 2y to this side. So keep your x's and your constant on one side, and keep your squares on the other side. Now let's just flip this around and make a space so we can complete this square. What happens if you add to one side, you also have to add to the other side. So we're going to make a little space over here. Whatever we added to this side, because it's an equal sign, we have to add to that side. This completing the square was a little, it's almost the same as we did before, but we're keeping everything on two sides. Before we kept everything on one side. So wherever we added, we had to subtract. This I like a little bit easier because if you add to one side, you add to the other side, and you don't forget to take care of that part. So again, back to completing the square. We take your middle term, b. We take half of b. What's half of 2? 1. We start like this. 5 plus 1 squared. Then we do 1 squared. What is 1 squared? 1. If we add it to this side, we add it to this side. So this left-hand side now is complete. And this side, we just have to combine like terms, and we still have to get it to look like that with the x minus something in parentheses. So what can we factor out of here? A 4. We need to get x by itself. Oops. I'm making a lot of mistakes. Now we are where we were yesterday. We're lined up to your formula. Here's your formula. Good? We completed the square. We needed to get a square out of that because we had a y squared and a y to the 1 power, to the first power. So we needed to get a square, a perfect square. So we pulled our anything with the squares in that variable has to go to one side of the equation. The other variable and the constant stay together also. So we took this, we took the middle term, half of that, squared it, added it to both sides. Combined like terms and factored so that the coefficient of x is 1. Notice your coefficient of y is always 1, your coefficient of x is always 1. Now we can line this up. We know your vertex. What's your vertex for this then? Do the x first. 8, negative 1. X always comes before y. We know your vertex. We know 4p is equal to 4. Therefore, p is equal to 1. It's positive. This is a y squared. Which way is this going to open? To the right. Y is open right and left. If p is positive, it encompasses the positives when it opens. If p is negative, it kind of encompasses the negative ones. Think of it that way. So, this brings us back to what we learned originally. We sketch. So figure 8, negative 1, somewhere here, we're opening up. Okay, we've got to find our focus point. Oh, sorry, we're opening. Yeah, I'm having a bad day today with my, we're 8, 1. We're opening to the right. We need to find along this axis, we need to find our focus point, and we need to find our directrix. Sorry? P, no, P is positive 1. We factored out a 4.
No, vertex. When you drew the...
Oh, it's negative. Oh my goodness. I need to go back to bed today and start over. You know what happened? It's Rich's fault because yesterday you kept insisting it was Friday. You kept insisting yesterday was Friday. So I said, oh good, I was in Friday mode. This is my Saturday mode. My day I just get up, have a cup of coffee. I watch recipe rehab. This is my relaxing day. Okay. Alright, so let's start this again. It's okay, come on. Just take one of each of those. Alright, thank you for your help on this. So we have 8, -1. So, guys, tell me what the coordinates of the focus point is if I am moving P units to the right. Good. So your focus is 9, -1. Everybody can see that? These are the parts we had to find. Now, your directrix moves the opposite direction. It's a line. So move the opposite direction. You're changing your x. So if I go from 8 to 7, my directrix is a line with the x coordinate. So my directrix is x equals 7. This is your directrix. If you have trouble, move the point first. And then, because this is an x equal, take the x value. Now, yesterday we added your intercepts. We're going to do your intercepts again. X-intercept, Y-intercept. Even though we can tell that there's no Y-intercept, we need to prove it algebraically. So for the X-intercept, we plug Y of 0. Any of these equations you like. This one, right here, before you factor this, is probably the best one to go. It's the best one to do because otherwise you're going to have to refactor it anyway, redistribute it. So if I go to this one, and it doesn't matter which one you use, I'm going to put a Y of 0. So this gives me 1 squared is 1. I add 32. I divide by 4. Leave them as reduced fractions. So if this guy is really 32 over 4, this could be 33 over 4. Just slightly, it's very wide. It's a wide one. So it's slightly to the right of it. So my x-intercept is here. Now my y-intercept, take this equation and plug in x equals 0. This is going to take this guy out, right? And it's going to say y plus 1 squared equals -32. When you take the square root, this is not possible. So there are no real y-intercepts. Everybody good? So all we did today extra was get it to that format. And then we continued with yesterday. We're going to do like 2 more of these. So by the time we get through this, it should be starting to get a little bit more familiar. I know you would always look at the ax squared plus bx plus c, and that's what we complete the square with, and that's what we always work with. So we just changed it up a little bit. If I had to just graph this, God bless you, there's no way I could sketch from that. No way. I would know it's a y squared, but I have no idea, and even negative y squared, I would think it went the other way. I have to get it into this format, into your vertex format, in order to be able to graph. And we are finding your zeros without factoring. We're finding your zeros using your intercepts, so that's a good thing. Questions?
I don't understand how to get to, like, I know what to do now after you get to where the arrow is.
Okay.
To y minus k, I know how to do that now.
Mm-hmm.
How do you get to that?
We took this, we said if it's y squared, get anything related to y on one side. And you're going to have to complete the square, because it's got to be y minus k squared. So we gave it a term so that we could complete the square. To complete the square, you take the middle term, half of it, then you square it, put it here. This guy right here, this is what factors into y plus 1 times y plus 1, which is your y plus 1 squared. That's how we complete the square. So if we add one here, we have to add one here. So we do. We combine like terms, factor out the 4, because we need a coefficient of 1 for our x. We need it to look like your formula. That's what I'm saying. If you write your formula down, it kind of helps, because it kind of tells you, whoops, you got to get x by itself, the coefficient 1. You're going to have to factor out a 4. Okay? All right, let's try another one. I need your undivided attention. I don't want to hear on Monday, I didn't get it. I'm not going to take that on Monday. Now, this equation has a fraction, and we don't like that F word fraction. So we're going to get rid of that denominator. Multiply both sides by what? 6. And since this has a negative in front of this, and I want to get rid of that negative, what can I do? Negative 6. So let's multiply both sides by negative 6. Okay? I have an x squared parabola. So I'm going to write my format up here so we can follow this format and make it look like this. I need it to look like that. God bless you. So in order to get that square, I have to complete the square. I need to get my x's by themselves. Add 2. Good. And I like to get my x on the opposite side. So reflex. Leave a little space, a third term, so you can complete your square. If you add to one side, you add to the other side. Remember, you don't want the coefficient of x to be negative if you're going to complete the square. You're going to factor out a negative 1. Yes?
They're all adding. They're all adding into them.
Yes. If you add to one side, you add to the other side. That's why when we did it together in one row, we had add and then subtract. And remember,
is it always going to be adding, or is it going to be subtraction too?
in this, no, because we're going to put it on both sides. So if we add to one side, we add to the other. Same routine. So now, take half of the middle term, which is half of 4, 2. Guys, follow me. What's 2 squared? 4. 4 goes here. 4 goes there. So this guy is my square. Combine your like terms. Now, I still need it to look like this. I need it to say y minus something or y plus something. So what can I factor out to make my coefficient of y be 1? Negative 6. That gives me, what's this term? Minus 1. If I take out a negative 6, this is a minus 1. So I'm in my format. Good? Go ahead. Well, we couldn't use x squared plus 4x because we wouldn't be able to get an x plus something squared. So what we did was we put a third term in here and we completed the square. We made it be a perfect square. It wasn't a perfect square here. And we couldn't possibly factor this out. You can't do this either. That doesn't get you to a square. I need to get something that's giving me that x plus something squared. So to do that, we leave a term here, leave a blank, take half of the middle term, that's your x plus 2, because doesn't this factor into x plus 2 times x plus 2? That's your perfect square.
Like on the bottom, where you say x plus h squared.
Oh, I just put the formula so that we can line up to, so we can line up and pull out your vertex and your parts. Oh, thank you. X minus. Oh, that's what you were getting at. Thank you. I can't write and talk today at the same time. All right, thank you, Kai. So now, let's pull out all our information. What's the vertex? Negative 2, 1. Good. Is this gonna, oh, let's do P. Negative 6 is equal to 4p. Let's reduce. So P is negative 3 halves. information all together. So if I'm an x squared and my p is negative, which way is this opening? Down. So let's sketch. So let's see if I can get this coordinates right. Negative 2, 1. And here's my vertex. It's opening down. Somewhere it's going here. Now, here's why we do your intercepts. Where do I go? Do I go above this axis? Do I go at the 0, 0? I don't know where my intercepts are. So for now, I'm just going to sketch and see where it falls. I know it goes down. This is my sketch. I don't need you to redo your sketch when you find your intercepts, but I need you to make sure that your intercepts are feasible. So P is moving me down here. I'm at negative 2, 1, and I have to go down 1.5. My focus point is going to be here. My directrix, a line over here. So if I'm moving vertically, I'm changing the y. This is 1. I need to go 1.5 down. So I come down 1 and down another half. So what's the coordinate? Negative 1/2. Negative 2, negative 1/2. You can use your formulas, but I don't give them to you, so they're really hard to memorize. It's better to get a feel of which way you're going. You kind of have to get a feel of which one to use before you can use it anyway. So your focus point, and I realize we don't do anything else with it except for just define it. And your directrix is going 1.5 above. So if you're at 1, you're going 1.5 up. You're at 2.5, which is, how do I write that? As an improper fraction. So y is equal to 5/2. Take your 1. Did I do that wrong, Kev? Negative 3/2, right. But when you go to the opposite side, you take the opposite sign. See, what this tells us is this. If you put this in your formula, when you add a negative, you're fine. When you go the opposite way, you're subtracting. When you subtract a negative, you add it. The directrix, if you look at your formula, subtracts. The focus adds. Because P is the distance between your focus and your vertex, which is true. So we're adding it. But look at your formulas. When we use your directrix, we subtract it. So when you have a negative, it's the opposite. You're adding it. But regardless of that, catch this piece right here. This negative is going to tell you which way it's opening. The 3/2 is just going to do your movement. Up 3/2, down 2/2. Let the negative just be open down. Let the positive be open up. And otherwise, you're going to be forced to put them into your formula. Try to get a feel for which way you're going. If I have to go up 1.5, I have to use the positive 3/2. If you look at your equation, it's h minus p is h k plus minus p. K minus p. Those are your directrix. So it's actually forcing it to go the opposite way. Okay, let's do our intercepts. X-intercept. Y is equal to 0. So I'm going to come here and use this guy right here. Doesn't matter which one I use. I like to use it before I factor. That's mine. So y is 0. This guy's coming out. Take the square root. Yeah, you get a radical. Make sure it's reduced. Plus or minus. Then subtract your 2. These are your x-intercepts. Now see if this makes sense. Radical 6 is somewhere between radical 4 and radical 9. Kind of closer to the 4. So we're a little bit over 2. So if I do 2 minus 2 something, that puts me right a little bit past this guy right here. Okay, and about the other way. So am I in the ballpark? Definitely. Don't redo your sketch unless it's really, really off. My y-intercept says let x equal 0. So let's take this guy again. X plus 2 squared equals negative 6y plus 6. So put this in, put your x in here, 4, subtract 6, divide by negative 6. So y is equal to 1/3. So you can kind of see it's just about passing right above the 0. And then, yeah, it makes sense. If this guy's forcing it to come a little bit over, this guy's going to cross a little bit above. Now, I noticed in the past, a lot of times when you guys do this, when we were doing our graphs of our functions and we did the max and the mins and all that, and when you found your x and y intercepts, sometimes they didn't match your diagram, yet you didn't go back and change anything or look to see what was wrong. Your x and y intercepts, everybody's looking around, your x and y intercepts have to match. Not exactly, because this is a sketch, but I can't get a y-intercept that puts me at y is 5, right? Because I'd be going in the wrong direction. So if you do, something's wrong. Another thing, if you go off your original equation, for your x and y intercepts, that'll really help you out to see if you're wrong or right. Because if you don't change anything, if you change something wrong, obviously you're going with the wrong one that you changed. If you go back to your original to do your intercept, that has to give you your true intercept if you do that correctly. So sometimes it's easier to go back to the original and solve from there and make sure it's all on track. Are we good with this? These require a little bit of work. We have to get it in the format. We have to complete the square. We have to find the p, sketch, and the intercepts take a little bit of work. Okay, one more. Another fraction. Yes. So, again, how do we get rid of this fraction? Multiply by 2. Now, you notice your x squared is also a negative? Can I multiply by negative 2? Can I not? And then later move it to the other side? Yep, you can do whatever you like as long as x doesn't stay negative to the very end. So let's multiply by, what do you want to multiply by? Negative 2. So every term, negative 2y, a negative comes out, the 1/2 comes out. What's a negative times a negative? A positive. Now be careful of this guy. A negative times a positive, a negative 1. Good. Now, you've got an x, oops, this is really not my day. You've got an x squared here, so we're going to fit this format. Leave your x squared and your 2x where it is, because we need that to be on one side. Add your 1 to the other side. And just reflect this. Do you have to? No, because your equations are reflective. But since the formula 1 is on the left side, it's easier to keep everything looking the same, because you got a lot going on. Now, we're going to complete the square. This term needs to get me a perfect square. I need it to come like this. So I'm going to leave a space here. If I do that, I also have to add to this side. So it's half of 2. 1. What's 1 squared? 1, 1. Okay, I'm almost there. I have this by itself, the 1 here, but the y has a negative 2 in front of it. I need it to be 1. So what do I have to do? Factor. What should I factor? Negative 2. And what am I left with? Y, factoring out a negative 2, minus 1. Okay? So, I have an x squared, and let's find p while we're here. So p is equal to negative 1/2. I have an x squared. P is negative 1/2. Which way is this parabola opening? Down. What's the vertex? Okay, so let's go from here. Am I good so far? Okay. I hope so too. -1, 1. Again, when we do this, we don't know how far, how wide, so we just sketch. We'll find our intercepts as soon as we do this. And if you wanted to, you could go find your intercepts first. Go from your original equation and find your intercepts. Question?
Is it a 2 after -5?
Yes, that's a 2. If you wanted to find your intercepts first and go to your original equation, find your intercepts. Look what happens to your x. Y is 1/2. So watch. Isn't this one easier? If I take this x out, I take this x out, my y is 1/2. It's showing me that my actual graph is going a little bit above that. A little bit wider. So maybe I want to just make sure, maybe I'll just start this one over. So it kind of is conforming. Do you have to do that? No, as long as you're in the ballpark. If you're not in the ballpark, then yes, change it. All right, so your focus has to come down 1/2. So I'm here at the 1. I've got to come down 1/2. So I'm not yet to that line. So what's the coordinates of my focus? Good. My directrix is a line that goes 1/2 way the opposite direction. So I'm at 1, 1.5. How do I say a -1, 1.5? How do I give the equation of this line? 3/2. Good. Keep them in improper fractions. 1.5, 3/2. Okay. Y-intercept. I went back to the original. Watch, I'll go back to the original. It doesn't matter which one you use. God bless. The original one was nice because when x is 0, this guy comes out, and y is 1/2. And yeah, that puts me in the ballpark. X-intercept. Y is equal to 0. I'm going to come down to where we completed the square. Always do the one with the square after you completed it, because you're going to take the square root, because you obviously are going to get 2 roots. So I'm going to come down to this one. Yeah, it's just a different form. I'm going to use this one because when you need to find 2 roots, you're going to have to take the square root. So it's much easier to do it here than have to worry about completing the square up there. You'd have to refactor, and you'd have to factor that thing and complete it up there. So come down and use your one with completed the square. So we're going to plug y in for 0. X plus 1 squared is equal to 2. They do work out nicely once you get them going. Don't forget your plus or minus. And we can kind of see the square root of 2 is a little more than 1. It's 1.4. So if I add that, I'm slightly over. Doesn't that put me slightly over? Slightly over and slightly to the other side. So I know what my x-intercepts are, and I know what my y-intercepts are, and I know my p, my focus, my directrix. I bet you didn't think you could know this many things about a parabola. I bet you're amazed at yourself.